today is probably going to be a long session, probably close to 45 minutes, maybe even an hour, where we go through all the aspects of Gruff. I divided up the lesson in little pieces so that we later can put it on YouTube where people can actually go back to certain lessons and try without sample data and Gruff at hand, do what I did today. So, well, the highlights are of our tool Gruff is to navigate large and very complex graphs in a user-friendly way. I can't even imagine sometimes how other people go through the contents of the triple stores without an official tool like Gruff. We'll show, and this is a very new thing that just came out in the latest version in 5.0, but we can actually now do work in the graph view on the screen, find very interesting patterns on the screen, and then if we see an interesting pattern, we can highlight the nodes in the pattern and actually turn that automatically into a Sparkle or Prolog query. So that's one of the new features I'm going to show you today. I'm going to show you how you can find links between nodes automatically. So instead of clicking around in your graph trying to find your way from one place to the other, you can do discovery by just taking two nodes and ask the database to connect to nodes. And then we'll play a little bit with Prolog to show how you can also use Prolog to explore the graph. And then some other things that people have asked us for. One thing is we now have, we can start up Gruff, and then within Gruff start an HTTP server, and then you can write applications that actually control Gruff remotely. And you can do that from every programming language. So it's a new, very interesting feature that we have. And then another thing that a lot of people ask for is that we want to show pictures for nodes. And so at the end of the demo, I'm also going to show you how to do that part. Okay, so now what did I do? I divided up this webinar for today in 11 short lessons. Yeah. First, I'm going to make sure that you know what kind of graphs we have and what we have to download for the webinar today. And I'm going to show you the basics of managing triple stores, so how do you open one, import triple, display triples, and how you create indices. Then I go to the graph view, which is the screen that will be in most of the time, yeah, where you can look at your triples and see them as a graph, so as nodes and links. But sometimes you really want to see your subjects or your triples as objects, and then you have a good, well, then the table view is a great way to look at them. And sometimes when you have deep hierarchies in your data, and while navigating your hierarchy, you want to keep the context, then the outline view is the really handy way to go to your triples. Then we have several ways to build queries. So I'm going to show you the query view, where you can write Sparkle and Prolog in text. And then we already for some time had a visual query builder, where we just can use point and click to build queries without actually writing much code, and just basically find nodes, link them together, and then turn that automatically in Sparkle queries. And then the highlight is visual discovery, where in the graph view we just manually and automatically go around in the triple store to find things that interest us. And once we find that, we can codify that and automatically turn it into queries, and then save those queries and see how many times this interesting pattern that you see on the screen actually happen in your database. Yeah. Then lesson 9 is to control graph to rest, so we show that a little bit. 10 is a little database with pictures on nodes. And finally, for those who are interested, I will start up the server edition of AllegroGraph and then again connect Gruff. Yeah? But most of my lessons will actually be done with the standalone graph. Yeah? So let's begin with the first session, or the first lesson. So we actually at France have two versions of Gruff. There's one that we already have for about, I would say, 3-4 years. Yeah, it's a version of Gruff where AllegroGraph is built in. It works on all platforms: Windows, Linux, Mac, 32-bit, 64-bit. It's perfect for exploring small and medium-sized data sets. And so for the demo today, I'll mostly be using that one. But if you want to do real stuff, so if you work with large databases and production systems, and you need an enterprise database with transactions and asset behavior and everything else you want from an enterprise database, yeah, then you want to use version 5 for AllegroGraph 4.10. Yeah. So let me just, if you go to the download page for Gruff, yeah, then you'll find this, well, this table of things that you can download. Yeah. For today, I will do Gruff AllegroGraph 3.3. You just only have to download this particular file, yeah, extract it, and click on Gruff and you're in business, because AllegroGraph is all set up within that. At the final lesson, we'll show you how to actually download the server and start the client version. Yeah, but for now, this is the version that we're going to use. And the next part is, so what I'm going to do now is I'm going to create a new triple store. I'm going to load some triples. I will show the triples on the screen, remove the triples again from the screen, create an index, and then search for something. Yeah? What I'll usually do is also tell you what shortcuts you have to use or where you can find a particular command. But let's get to the first demo of managing your triple store. So here I have a shortcut on my desktop, Gruff 5.0.10 for AllegroGraph 3.3. I start it, and let me display also the legends. So I go to View and Show Legend. And then I'm going to create a new triple store. So I click New Triple Store. And this version also will work on remote triple store. So if you want to work with a local database on your hard drive, then you have to fill in the name of your local machine. And we already suggest what the name of your local machine is. My local machine is JA7. Your name will undoubtedly be different. But by doing this, I say I'm using the local machine. Then I create a database. Well, I'm just put it in my documents. So I say, let's do actors. So what I'm going to download later is a little subsection of the DBpedia with actors and movies and the roles of actors, whether they were an actor, whether they were a director, where they were born, and stuff like that. So I'm creating a database called actor.db. Say OK. And I already had one, so I'm overriding it. Then I tell the system how many triples I expect. Now, it doesn't really matter what you fill in here. This is important if you're going to do literally hundreds of millions of triples. Then it really makes a difference to have kind of an estimate. For small numbers, it really doesn't matter. But I'm putting 200,000 triples. So now I have a database, and I have exactly 0 triples, as you can see at the top here. So now I go back to File, and I say Load Triples. And I have a choice for various kinds of triples that you can download, but I'm going to download, load triples from an ntriples file. And see here I can choose actually from a file or from the web. So if you have an IDF file somewhere on the web, you can actually download it straight from the web. But let me do it from a file now, and then I will go to a directory where I know where my file is. See. Hey, I have it in actors.ntriples. Oh, yeah, here it is. So I have the file called actors.ntriples, 25 megabytes. When I open a file, I also can specify the name of the graph. And usually it's a full URI, but you can, just for fun, also just type in a literal, doesn't really matter. The system will start downloading triples. And now we can see here at the top that we have 166,497 triples in the system. Yeah. But now we want to look at some triples. So just for fun, if you want to see how your triples look like, yeah, then one quick command to get some triples on the screen is to click on Display, and then display all triples up to a limit. So here, I show some triples. Yes, so I see some triples with Dennis Hopper, some triples for Ronald Reagan, James Russo, etc., etc. Yeah, so we see that what we see on the left-hand side is green means that someone is an actor, and blue means that someone is if something is a movie, and somehow the DBPD forgot to type for all the other movies here. Yeah, not a problem. So now I need to remove the triples again from my screen. So I can say remove all nodes, and then they go away from the screen again, so I have an empty screen. And for almost every triple store, well, if you want to work with triple store, it's always very important to have a free text index on all your triples, because that makes it really easy to navigate. So how do you make a free text index? You click on display, and then you say edit the free text predicates. And here you see a list of all the free text, so all the predicates in the system for this tiny little database. And in general, it's just good enough to create a free text index for IDF comment and IDFS label. Yeah. So now I'm indexing all the triples for that. And so now I have a free text indexed. And now I can look for something like, well, Arnold Schwarzenegger. Yeah, let's look at Arnold. So what we do is we see all the triples that somewhere in the triple have Arnold in them. Yeah, so I'm choosing Arnold Schwarzenegger. So here we have Arnold. And then just for fun, let's also find Kevin Bacon. Yeah, and so I find Kevin Bacon. So now I have Kevin here. And I'm going to explain how I do this later, but let me select some predicates to connect these two people. I hit the letter P, and I take starring, director, and DS, and can actually say, how are Arnold and Kevin related? And here you see, let me change the canvas a little bit by hitting smaller than. I'm going to explain that again later. Okay. And now we see that Kevin played in this movie, that Kevin Pollack, who played in this particular movie with Arnold Schwarzenegger. Yeah, so you can see how things are all related. So this is another way to get things on your screen. So this is just the basic management of triples. We open the triple store, load up the file, and we check that the triples are in the store by just displaying all the triples up to a limit. And then finally, let me see here. There's my PowerPoint. And then we created a free text index, and we searched for something using, we searched for some of the text, and I was actually using semicolon to search, and I should have explained that. Yeah, so see here. Okay, so that was managing the triple store. Now we go to the graph view that I just showed you. So the graph view is the thing I already showed you just a few seconds ago. It's the screen that I spend 80% of my time in when I work with Gruff. And so what I'm going to do again is I'm going to open another database, and then I show you some easy ways to get triples on the screen. Because a lot of time when we have people that use Gruff for the first time, they say, hey, I look at this blank screen, but how do I get the triples there? So I'll just give you a few ways to do that. Yeah. So let me go back to the database. Here it is. And I'm going to open a healthcare demo. So this is actually a database that contains about 100,000 clinical trials, 1,800 FDA-approved drugs, 4,000 diseases, 4,000 side effects, and that all linked together because clinical trials talk about drugs and side effects and diseases. Then we also have healthcare records in there, unstructured notes that were indexed with a mesh ontology. Mesh is an ontology from the medical domain, and we also have everything indexed with SNOMED. Yeah? So this way we can actually take electronic health records and link them all the way down to clinical trials. So let me give you a quick demo. So how do I get, so I have all these 13 million triples here. How do I get something on the screen? First thing I showed you is already that display all triples up to a limit. And by the way, I apologize, when you do webinars, I can't use my 2000 by 1000 resolution on the screen, so it kind of always looks a little bit crowded. But anyway, here you see some triples that we have on the screen. Yeah, one way to do this, and I can actually zoom in, yeah, this way. So I can zoom in the triples, and I can reformat the triples again to see if I get a better picture. So I'm using the letter R to reorder the graph. So this is one way to get something on the triple on the display. Just use display show all triples. The next way was to use a free text index. So let me get rid of the triples. I use remove all nodes on the screen. So the next thing I'm going to do is to display triples by free text index, or nodes by free text index. Yeah. So I'm using the semicolon usually. I never do this by using the menu, but I do this and say I'm interested in, say, ibuprofen and cancer. There's actually only one clinical trial that discusses both. So let me do another query. Let's just search for ibuprofen. And I get long list of things that have ibuprofen in them. Yeah, I select few of the nodes, and then here, oh, I have to go a bit bigger again. And so here I have some clinical trials on the screen. So say I want to explore this on the screen, then one thing I can do is can right-click on the node and say display linked nodes from a tree. Yeah, and here you see that this thing has a brief title, criteria, discusses certain drugs. So I could actually click on the drugs that are discussed. Yeah, and so now I see the drugs, and I could do this for here. You can say, let's look at the well, let's look at the mesh. Well, let's look at something that's more things here. Side effects. Side effects of this guy here. Oh, I have to click on it. On the side effects. Okay. Yeah. So here's some side effects. Anyway, I can do this by right-clicking, but that's of course a very painful way to do this. So let me go take a step back, and a very important command, maybe the most important command in Gruff, is the letter Z, or the key Z, that will take you back a step. Yeah. So now we're back by using C. So the next thing I'm going to do is to press the letter P. Maybe let me first do it here. Display. Where is it correct? Oh, yeah, display. Okay. What I'm going to do, I just hit the letter P, and what I see is all the predicates for clinical trials. And I'm only interested in exploring these for the moment. I'll select more later. And so I selected 4 predicates. I say OK, and now I hit the letter F. Okay, yeah. Actually, so let me just show me. It's on global options, and then you can say select current predicates. So this is where the letter P comes from. Anyway, so we're here. Now I can hit the letter F, and what you see now is I linked all the diseases, drugs, and side effects are suddenly shown in the picture. And if there were already things on the screen, it will connect to it too. So if I click on this guy here, then you get all the things from here. And if you click on this, you get them from them. And if you click here, so here you see already how this is pretty much connected. Yeah, let's make it a little bit smaller. Refocus. So every time when the screen changes, I actually push the letter R. So this is one way to get more things on the screen, and I showed you the letter Z to go back. I showed you the letter R to reorder, so I can reorder the graph. So we use a spring layout algorithm. If I hit the letter D, I nudge the graph. So sometimes the graph is not entirely finished when you look at it. R means vigorously try to do it again. D means actually here is, I think, the layout. Here's the answer. So redo layout from scratch is letter R. Update layout incrementally is D. And update layout really strongly is 5. Okay, that's probably good. All right, so now one thing I also showed you is to make things bigger and smaller. So I can zoom in with my mouse and just use the wheel on your mouse to go deeper, go all the way down, deep. For people that do it without a mouse, you can actually use comma and dot. Let's see, where's the shift? Sorry, shift. Yeah. So shift comma will zoom out. No, zoom in. And anyway, just play with it. I always get confused by the direction. Yeah. So this is the and you'll find it in your script later how to do this. Then another thing is sometimes you have a lot of things on your screen, and you see that things get kind of stuck. Show all. That's maybe a little bit too much. Yeah. So you see your screen gets really big. So one thing you also can do is actually make the canvas bigger or smaller. So if you do smaller than and bigger than, so I think here it is make canvas larger is actually the dot, and canvas smaller is the comma. So when you do this, look, watch the bottom of my screen. Yeah, so I make actually the canvas bigger. So now when I do this again, it will use a bigger screen to go to various places. Yeah, so it's one way. By the way, you can always see on the left bottom side, it's kind of a little, I don't know how you call this, but you can actually use this to navigate for the screen too. All right, so that's something you can do with the canvas. I already showed you how you can delete nodes from the screen. Yeah, so for example, if I want to delete this guy here, I can use the letter X. So here's the whole thing. You can remove one node, you can remove all nodes, or you can actually have a graph eraser. Yeah, so just for fun, I can click on this and do the letter X. Now this guy is gone. But I can also do Ctrl-Alt-X, yeah, and I can just erase part of the screen. Yeah, so it's like a drawing program, except I can now remove parts of the screen. And I can reformat again and look at the screen. All right, yeah, so this is very handy to have. Then also you see here this empty guy here, not connected to anything. So one thing which you can do if you have too many of these things that are loose here is use remove orphans here. Remove orphans. Where's the remove orphans? Or here's the remove orphans. Or Shift O. Yeah. So now you see that all the ones that are not connected are instantly removed from the screen. Another handy thing to know. Then sometimes when you're looking at the screen, you know on the left-hand side you have all the names of the predicates. So if I click on diseases, you see those, you see the drugs, you see the side effects, you see the targets that are linked. Here you see the classes of the nodes here. By the way, so you can also, so here, this is one way to look at the names of the predicates. But actually, if I hit the letter N, I also will see actually what the name of various predicates are. But usually I think it's really bad for the aesthetics on the screen, so you can just play with it. Yeah, you can just turn it on and off. Another thing that you might notice here, if I put my mouse on, say, hemorrhage, then what you see at the bottom, left bottom, is the full URL. So one thing that we do is, well, you notice two things, by the way. One thing you notice, let me move here, is that the full URL doesn't even have the name hemorrhage in it. And that is because when we display nodes on the screen, we usually use the name, the label of a particular node. So we don't do the real name, but just the label. So just let me show you what it would look like if I would use the label, not use the labels. Yeah, if I, let's see, Control F8. Yeah, so now with Control 8, yeah, don't worry, it's in the script, you'll see that later. You're not using the labels anymore. So suddenly it becomes kind of a really boring graph because you only see codes. When I do Control 8 again, you'll see that I show things by label. Yeah, so that's important. Okay. So this is some things that you can do. Now, what you see here is we used the label, yeah, to display. But sometimes, say you download you download Freebase, then nodes won't have a label, but they will have a name. So in that case, it's always very handy to look at the node label predicates and make custom predicates for node labels. So here, for example, you can see that if we have a SCOS database, yeah, SCOS triple store also won't have a label, but it will have something like a preference label and an alt label, then Gruff will also use this one. And for Freebase, I would add the Freebase predicate for name, and then suddenly, instead of using these long identifiers, you would see suddenly the normal name of an object. I hope that is clear. Yeah. Let me see here. Control-Shift-8. Oh, that's it. That's it. Yeah, Control-Shift-8. Sorry, this is the one. So, yeah. So here you see that Control-Shift-8. Oh, it's in the script too, by the way. This is how it really would look like, but you can see that's just really ugly, but sometimes very useful to see it. And this will toggle it off again. So there's two ways: looking by label and seeing the full URL. Okay, let me continue. So let me go back in the graph a little bit. And so here I have a part of the graph, and say I have this part here. And now I want to connect something that's completely unrelated. Yeah, so I can take a topic, romantic kissing, that sometimes works best. Yeah, there's one clinical trial that is initially unrelated to all of these. So what I can do is hit the letter Shift-F and drag it to one of the other clinical trials. Yeah. And what it will try to do is find the shortest path to get from this clinical trial to this clinical trial about ibuprofen. Now, AllegroGraph will find 3,600 paths. So you have to select a subset to see some of them. So you can choose a few of them, yeah, like this. And now you will see how things are linked to anxiety and then go to the particular clinical trial. But the graph completely changed, so that's kind of painful. So one thing you can do is, let's do this again. I go to Z, and I actually pin this node to the background by hitting the letter I, and I select this clinical trial, and I also hit the letter I. So now I've pinned it to the background. So now if I find the shortest path again, I get my path, I select a few links. Now when I look at it, you see that they're still here, and now we can see how things link to anxiety, to this clinical trial about pain and hypersensitivity, all the way down back to this particular clinical trial. Yeah. So very important to remember I if you're doing something like this on huge graphs. Now sometimes you're going to find a path. Yeah, and there's various things you can do. One is you can actually check to see if, and I'm going to show this in a second, but let me just do it for now. You can double click it and you get in the table view. I'll look at it in a second. But so as you remember, I tried to link things together through diseases, drug side effects, and target, but sometimes there's nothing there. So if there's nothing there, then Gruff really can't find your can't find a link, obviously. So going back to the graph view, another thing is sometimes you might have too many connections, too many predicates that you select with, and then the branching factor is that big that finding a path won't happen within 20 seconds. Yeah, because it's just a combinatorial explosion. But sometimes you want to have less predicates. Sometimes you actually want to have more predicates. And by the way, if you do this on big databases, it really helps if you have a solid state drive and a lot of memory. Yeah. Then also finding stuff in big graphs is a little bit faster. Then some final things. Let me delete the graph again. Then we get something like what is it? Heroin. Yeah. And get some clinical trials on the screen. Let's see how they're linked together. Then one thing I can do is say I find this an interesting pattern. I can actually save a layout. So I can save layout state. And I can say, well, heroin. So now I have a layout. And if I lose this, I can load it again by going File, Load Layout State. And I can go to, hey, where is it? I thought I had heroin. Oh, here, heroin.layout. Yeah. And so here I have my graph deck. So yeah, and it's a very simple text file that you can send to other people, even in as email. And I guess that was about all I wanted to show about the graph view. So let me go back to the PowerPoint presentation. Yes, so I did a lot of stuff and I overwhelmed you, but everything I showed you was in the script. Yeah, so I show you how to get stuff back by pretext index and displaying all triples, how to get products on the screen, how to find something with pretext indexing, how then to explode nodes with letter F, how important it is to remember Z to go back to a previous stage, how I can reorder graphs. And I'm not going to go through all of this. It's all in the script in the PowerPoint presentation that you get later. But everything I did is described here. Okay, so let's go to the next part, which is the table view. So let me go back to the triple store. Yeah, so note here how I had some nodes on the screen, and I'm looking at as nodes and links, but say I wanted to look at one of those separately. I double click on it, or I hit the letter T. So here you have all the views that we have: graph view, table view, outline view, query view, graphical query view. And the letter T will get you to the table view. And so here we are, yeah, in the table. And the way you read it as triples is where you see, well, this triple this clinical trial 268814 has the brief title, The German Project of Heroin-Assisted Treatment of Opiate-Dependent Patients. This clinical trial discusses, oh, it's a long text here, discusses some diseases, asthma, convulsions, and some drugs, some side effects. Now, if I'm interested in, say, cocaine, I click on cocaine, and now I can see here the chemical formula, the lookup name, the description of it, the mechanism of action, everything else that's interested, the possible diseases that it could deal with, some synonyms, and then other clinical trials that talk about it. And then we have in a new clinical trial that talks about cocaine and dicipramine. Well, I can go to another. Actually, there's no more clinical trials. So I actually can go back. I'll go to another clinical trial. Talks about abuse. There's a lot of trials. So now I'm in the disease database. And anyway, you can see how I jump from one spot to the other, but in a clear table view, and some people prefer this in certain cases. So that is the table view. And again, if I want to look at the full URLs of things, then you can hit the letter 8 and you see the full names for the predicates and the full names of this, but it's so ugly that most of the time we just use this. Yeah. And actually, if you wanted to add triples, this is the place where you can right-click a value, and then you can create a row for a new triple, or you can create a row for the same predicate. You can even delete triples, so you can even add triples this way when you wanted to. So I guess that's about all I want to say about the table view. Yes, let me go back here. So the table view is, oh no, I forgot one important thing to mention, by the way. If you look at the table view, this is not a good example. Let me get to another, say, cocaine. So now looking at cocaine, then what you see here at some point is a big gray line. Yeah. Above the gray line are all the tuples that start with cocaine. Yeah. Below the gray line is all the tuples that point to cocaine. Yeah. So here above the gray line you would have something like cocaine is of type drugs. Yeah. So normal order. Below the line you have the inverse. You say trial, this trial here discusses drug cocaine. So this is the reverse indices. You see, yeah. So for example, this trial mentions this drug, or sick sinus syndrome is has a possible drug cocaine. So it's in the reverse direction. It's important to realize that. Yeah, that in this view we show both directions for triples. Okay. So now go back to my presentation again. This is the table view. Then we have an outline view. Yeah, sometimes you have really deep hierarchical data, and you want to kind of see the whole hierarchy when you go through the hierarchy. Yeah. So let me try to see if I can find a nice hierarchy in my healthcare data. So I'm going back to the here. Let's find a clinical trial that mentions mesh smoking cessation. Okay, so this is one. Here I have a note called smoking cessation, and it's something out of mesh. So if I hit now the letter O, I am, okay, so just for fun I have to, let me use all the, get me some more predicates that I have to look at. So let's select all the mesh predicates. So I hit the letter P and got here. Got the SNOMED findings, and because mesh is a big subclass hierarchy, I also select subclasses. So where's my subclasses? Here's my subclass of. Yeah. So now when I click on this, you see the hierarchy, and what you see is that the blue ones is where you drill down, and the black ones is where you would go up again in the hierarchy. Okay, so we click on cessation, subclass of smoking, which is a subclass of tobacco use cessation, which is a subclass of behavior, which is a subclass of behavior and behavior mechanisms, which is a subclass of attitude, which is, anyway, you get the point, yeah? And I could click on anyone else here, and I could click on this, yeah, and now we go actually up the chain. So this is a disease of lymphoma. Okay, that was the outline view. Let me just continue. So we did the outline view. Then we have the query view. Yeah, so this is, let me go back here to the database. And for this, we are going to use another database called FIBO. So some people in the audience might know what FIBO is. It's an attempt by the banks in the United States and the OMG to create an ontology of all the concepts that are used in banks to make it a lot easier to get oversight over what's going on in banks, to make it easier to do rollovers, to do queries and data analytics to figure out to what extent certain banks are at risk. But it only will work if everyone is using the same concepts. And so, well, there's a group of banks that work this, but the demo or the file I'm showing you here is created by David Newman of Wells Fargo. He uses this tool to actually display data for these ontologies that they're building. And so let me open that file. It's FIBO. So here is the have opened the database. And again, let me display some triples. Yeah, so here you see some triples. You see derivative contracts, and that are subclass of swap contracts, and this is a subclass of something else again. You see parties that certain banks. You see how banks are related to each other and how they are parties in certain contracts. So it's a huge ontology and a demo with instances too. So this is the data set. And then for queries, well, normally this is the query view. Yeah? So I can write queries in any way I want. I can say select star where, say, X is X, well, subject, say, predicate object. And let me show you the first 100. I do the query. I see here the results like I would see in a relational database, subject, predicate, object. And I can save this as a comma-separated file or as a text report. But usually what you will be doing is create a visual graph out of your data. Yeah. So here you would see some, let me turn out the names, some random triples on your screen displayed. But we also can store these queries. So David Newman has a whole series of queries that he usually likes to show. So let me show some of those. Let me see, Dropbox, and then Wells Fargo. So here is a list of queries that he created. So here he created a query that looks at all the subclasses of swap contracts. So here is a here you look at all the classes of swap contracts. So here's, and this is of course not a lesson to teach you any Sparkle. There's lots of good books out there and courses and tutorials. Yeah, this shows you just the mechanics. And so here's a query to find all the subcontracts of interest rate swap contracts. I do the query, I get my results. And notice that if you do this, so you would do this like a relational database, it's almost impossible to see the links between all these things. Yeah? It's just table view and too much data out there. If I create a visual graph for this, yeah, and let me make the canvas a little bit smaller, again, and reorder, yeah. Then here we see all the different types of exotic contracts, which are currency, IR, swap contracts. So you see a whole array of kinds of interest rate swap contracts. Yeah, so this is one type of query. I can take another query, for example, ownerships between companies, and you see how you look at companies that own other companies that are again owned by other companies. So the query, again, here's the results, and if you just look at the table, you hardly see any relationships. If I look at the visual graph, I see lots of relationships between banks. Now, everything is of type body corporate, so let me remove that line. So this looks already better. Yes, so now you see ownerships relationship between various banks. This guy is kind of lonesome here. Now, I do know they have a connection with Wall Street Bank, so let me just look at one. I know that there's a trading relationship with these banks, so I could actually say is trading with, and I actually probably could find a link here. Yeah, so now at least he's part of the family through all kinds of trading relationships. And then we could look at all the other guys. Oh yeah, here's another thing. Sometimes you want to find out if, given the predicates that you selected, there are still nodes on the screen that have more children. If I hit the letter F3, or if I hit F3, then you see whether or not something has unseen current links. Well, you have to be yellow to be unseen. So let me go back a step. So here you see, if I now exploded this guy here, then suddenly everything has a relationship and all the links now are satisfied according to the set of predicates that I chose. If I do more, let me just do a few, just clicking predicates. Now, of course, everything has more predicates again. And now if I go here, you see how slowly everything is getting saturated, given the predicates that I chose. Sometimes very handy to have. If I hit F2, I get my normal colors back for the types of nodes that I have. Okay, so, but again, I mostly talked about the query view, and I can do both Sparkle queries and I can do Prolog queries. Then we have a visual query editor. So these queries you have to write by hand, and of course it's kind of hard to know what the predicates are and how to fit everything together. So we have another query view. Let me first get my healthcare demo back. So healthcare. So I have my new database back. And we have one screen. So let me do this guy here. See if I have anything here. So we have one screen where I can build queries visually, no code. Almost everything on the screen works like the normal graphical view. And here's the important things to remember. To right-click on the screen to create new variables, and to right-click on variables to create new predicates with drag and drop. So let me just give you a quick demo of that. Okay, let me go back to the healthcare database and get a layout on the screen. So I'll go to the Dropbox, go to so I have the healthcare demo, and I want to get a layout on the screen. So I'm going to the Dropbox, and I'm going to the Smart Logic demo. To my demo here, and I get something on the screen. Yeah, so here, what I do is I have saved in the healthcare demo a pattern that I found at some point on the screen. Yeah? So I see that Brady Tatum, which actually is a patient node, was taking a particular medication, which is a drug-inducing drug, which is a subclass of this particular thing, all the way down to hormones. Yeah? So I have various of these layouts. I have, I think, this one here, a much bigger one. And I see interesting patterns here. So let me just take, say, this clinical trial here that I have and this one here, and just get those on the screen. And so I have these guys here. And I select, because you now all know how to do this, I select some predicates. And I say drug side effects and targets. And let's take some mesh variables. And a subclass of. And so one of the things I could try to do is to see if I can find a link from one place to the other. Yeah, so I let the database find the link all the way from Brady Tatum to hypnotics and sedatives to say something like propofol, the thing that Michael Jackson died of, and then finally this clinical trial. So I find this an interesting pattern. So I can do this, and I check this. And some things like this have certain side effects like here. So what I saw is a pattern where I have a patient node where someone took a hypnotic, which is in this case was propofol, which was discussed in a particular clinical trial that discussed a particular side effect. So I can take this and I take this query and I take it here. And so now I have a query, except the query is kind of only has constants, so it's not very interesting. So I can say, let's take propofol and turn that into a variable node, so that it will be a drug. And there's a clinical trial, and let's turn it also into a variable node, clinical trial. And then there is a, this is a hard to see side effect, but let's turn it also in a variable node. So any kind of side effect. Yeah, so now I have a query that says, okay, give me anything with a patient node where the patient takes medication That's a subclass of something that is ultimately related to a clinical trial that discusses certain side effects. So I created this particular query in the query editor. It gave me the error a few seconds ago. And I can do the query, and here I have the results of this particular query. So the system wrote the own query. Yeah? So I went all the way from the graph view, yeah, seeing an interesting pattern, turning that into a query where I took certain elements and turned it into variables, then turn that into a query where you see the results here, where then if I look at the visual graph, I get these results. And then you see here we have Grady Tatum to, well, this patient note, described a certain hypnotic with this drug here, where there's a clinical trial that then talks about mental impairments, for example, or other things that might make people, well, for example, trip or fall or slip or whatever. Yeah, so here's a way to find automatic, so start with the graph, turn it into a query, and then ultimately do the query and find the same pattern again. And then I could go back in the thing here. I could say, well, I actually would like to see 100 results. Do the query again, create visual graph. Then now we see a much bigger one. But again, finding, so you create the data on your screen, you find interesting patterns, then you ask the machine to continue and to find more of those patterns in the database. So a very powerful tool. All right, so this was the discovery part. And finally, controlling Gruff programmatically through HTTP. We had various customers that wanted to play with Gruff, but they didn't want end users to have to click nodes. They just wanted to build an application where you found a certain pattern in your database, and then you just tell Gruff to display that data. Yeah, and then you still can do whatever you want to do with the data on the screen. So here's how that works. You have Gruff up and running, yeah? And then you, well, let me just show you what we do. So I go to Global Options, Communications, and I say Start an HTTP server, and say I want to use port 8000. So now I have a server up and running, and then I can do various things. I can say, well, say I want to let's see here, to hold back space. Oh yeah. Say I want to do this thing here. Yeah, I copy it, and let me make a very small window here. Here, this is okay. Here, this. This is the thing I want to do. Yeah, so now let me show Gruff. Yeah. So here we say localhost 8000 update layout redo is yes. Yes. So I'm using the browser to talk to Gruff, and I do this, and you see it was redoing the layout. Actually, if I can make it happen easily, I could also use the command lines and actually use curl to curl localhost : 8000 update minus layout redo is yes. Okay, so this is what happens. And then I can do, say, find a store name, or I can do something much more complicated. I could say find a path from one point to another point. Yeah, so here you say localhost 8000 find path, and the first node would be a particular node. The second node would be this node here, and then you want to keep the old node. So this is pretty complicated. So if I say open a database called Gruff2, and I think I have a layout for this. You remember that it was in temp? Yeah, okay. So here you see a part of the database with an ontology for the government and terrorists, etc., etc. So you will find For example, you might have a coalition partner, and you might have something like economic stability in this particular graph. Then the command that I will have here would be take this whole guy here, make a copy, go back here, paste it in there, and then this, oh, yeah, okay, of course, then I have to first select all the predicates here. So select all the predicates, which you also can do with the, and so what you see here is that from an outside browser, I can get Gruff to do stuff. So we have a full interface, a full REST interface to Gruff. So if I, by the way, you always can find help in Gruff by hitting the letter F1. Yeah. And in this case, if you then would go to HTTP interface to Gruff, then you would see that you can open stores, query stores, lay out triples, find paths between nodes, you can change the colors, whatever you want. You can control almost anything in Gruff just through a straight HTTP interface. Okay, so that's about controlling Gruff programmatically through HTTP. Then another cool thing is to actually use pictures in Gruff. So I have a little database. I think it's called family. Yeah, so let me show you what you have to do. So here is the I deleted a whole bunch. Using pictures for nodes. So here, this is what I'm going to demo to you. Yeah, we have a bunch of triples with relationships between the triples, and it's very easy to use. What you do is you have to tell Gruff what the predicate is that you normally use for pixmap maps. So if I have triplet from Jans has a pixmap pixel of Jans, then I can just tell the system that pixmap is the one I want to use. But then you tell the system where you store your JPEGs or PNGs or bitmaps or icons, yeah, and you do that with global options here, and then you can have pixmaps labels on your objects, and you will see those. So let me go back to the triple store, and so let me do display all triples. And what you see here, and it's a little bit too many nodes here, and the screen is too small, so let me reorder it. Yeah, and so here we see that this person, for example, is spouse of this person, and this person has this as a parent and this as a parent, and this person likes music, etc. Actually, just to show you how I can create triples on the screen, I can actually do Control D, link to another node, and then say recently selected predicates. Okay, so we don't have anyone. So then I can just do it again, Control D, into this one, type a URL. I can say loves music. Yeah. So I actually created a new triple in the triple store by linking. Anyway, this is a cool picture that especially, well, people all over the place like to go social networks, have pictures of people in there and find relationships. So this is how to use pictures in Gruff. And finally, last part, I'm already more than an hour in, how to use Gruff with AllegroGraph as a server. So let me close this graph here. So if you want to use with the full AllegroGraph as a server, you have various options. You can just go to the website, go to a download page, and you have to run in Linux, but then you can install the server. So you can just find various versions of the server here, and then you can install yourself. If you want to make life really easy, you can start the virtual machine. It's about a 2 GB download, but then everything is installed, Gruff, AllegroGraph, all the documentation, all the examples, all the example data files. Or if you want to, you can go to a hosted AGraph and you can start an AllegroGraph in the cloud. There's many ways to start a server somewhere, somehow. Yeah. And then you also need a different Gruff. So what you do is you go to a download page, and all my demos so far I did with Gruff for AllegroGraph 3.3. But for the server, you want to use Gruff for AllegroGraph 4. And so you, even I on Windows want to use this particular version here. And then you just start your virtual machine if you downloaded this particular one. And it takes a few seconds to start it up. So I played so much with this, probably got more than 100 gigabytes of data here. Okay, so I start, use the password AllegroGraph. And now I have my database open. Then I double click on AG Start. So by the way, I have Eclipse here, so if you want to do our all Java tutorials, you can just click on Eclipse and do whatever you want. Even Gruff is here. But let me start a database, run in terminal. And then one thing you need to do, I mean, if you are a VM expert, then you probably will want to give your VM a fixed IP address. If you don't have a fixed IP address, then you have to look in a terminal. So I use Ctrl-Alt-T to do ifconfig to figure out what the IP address is. Here's the IP address, the database, so it didn't change this time. So I have now a database running on the server. Yeah, you see some database stuff working. And now I can start Gruff again, but now I need the Gruff 5.10 for AG 4.10. So I start it. And then I can open Triple Storage. So I could have something like this, the healthcare demo again, test. So now I'm opening a database on the server. And now I have the database ready, and then I can do whatever I did in the whole demo, except this time I will be using the server edition. So when you start up, it will be a little bit slower to heat up the virtual machine. Yeah, so here's the everything I displayed so far. Again, I think I deleted as I showed you here. So here is now the first so many triples that are displayed, and then I can just do whatever I wanted to do again in this database, but now on the server edition. So this is the final thing that I wanted to discuss.